Hello guys, and welcome to Learn Extra. Today we're going to be having a look at number patterns, and we're going to be looking at the 3 different types of number patterns that we deal with in our syllabus. The first type of number pattern is our linear number pattern. So a linear number pattern, we're going to talk about what those are just now, an exponential number pattern and quadratic number patterns. Now guys, in today's lesson, when we do the exercises, we're going to do an exercise where all of the number patterns are linear, all of the number patterns are quadratic maybe in the next one and exponential in the next one. But one of the most important things that you guys have to learn is how to identify which number pattern type you are dealing with, because in a test or in an exam, and especially at the end of matric, we're not necessarily going to tell you what sort of number pattern you are dealing with. We are going to expect you to identify that on your own. So let's get going and look at the properties of linear number patterns. Now, linear number patterns are also called arithmetic number patterns. So just remember that bit of vocab. Those 2 things are exactly the same thing. And how you identify a linear or an arithmetic number pattern is that from one term to the next, there is a constant difference. Like, for example, if I go 2 and then 5 and then 8 and then 11. To get from 2 to 5, I need to add a constant difference of 3. To get from 5 to 8, I add 3 again. And to get from 8 to 11, I add 3 again. Right. Now, this one is pretty obvious, 2, 5, 8, 11. But there might be some number patterns that are not that easy to identify. So let's also remember this rule, that if a number pattern is arithmetic and I subtract the second term from the third term, that must give me the same answer than if I subtract the second term from the first term. This is how I prove that a number pattern is arithmetic or linear, by showing that this is true. And let's have a look. Our third term is 8. 8 minus 5, which is the second term, gives me 3. But 5 minus 2 also gives me 3. So definitely this is a linear number pattern. Something else that we must remember when we're dealing with linear or arithmetic number patterns is that we don't necessarily have to add a constant difference. We can also subtract a constant difference. So for instance, a number pattern such as this one, which goes 10 and then 8 and then 6, that is also a linear number pattern, but in this case our constant difference is -2, because we have to subtract 2 to get from one term to the next. Right. Let's have a look at an explanation of a linear number pattern. Well, an example rather, sorry guys. So we are told 2, 5, 8, 11, and we are told find the 1000th term. Now, very important, we first need to make sure what sort of number pattern we are dealing with. Otherwise, finding the 1000th term we might not do that correctly. So let's have a look. From 2 to 5, I add 3. From 5 to 8, I add 3. From 8 to 11, I add 3. So definitely, I can say that this number pattern is linear or arithmetic. Very important. First, establish what you are dealing with. Then we are going to have a look at the formula that we use. Now, guys, I suppose it's perfectly possible to sit with your calculator and add 3, add 3, add 3, 1,000 times, but it's going to take you forever. You're probably going to lose count at some point or another. And in most cases with number pattern questions, we do tell you to use an appropriate formula. So don't go with this business of adding 3 1,000 times. That's just a waste of time. What you can, however, do is use this formula, which will be given to you on your information sheet. The formula says Tn is A plus n minus 1 d. Now let's quickly just talk about what all of these things stand for. Tn is the nth term. So if you wanted to work out the 5th term, then you would make n5. If you wanted to calculate the 8th term, you will make n8. But basically, Tn stands for any term. You can then replace your number as you want. A stands for the 1st term. Very important that we need to know where our number pattern starts. So A stands for the 1st term. N again stands for which term. Which term do you want? If you wanted the 5th term, then n would be 5. If you want the 10th term, then n would be 10. D, finally, stands for our common difference. And our common difference is that value that we either add or subtract to get from one term to the next. Now, very often, the question is going to say something along the lines of, this one said find the 1,000th term. That's fine. But before I find the 1,000th term, I'm going to first come up with an expression for the nth term, right? An expression for the nth term is a general expression where the only unknown is n, and you can then use that general expression to calculate whichever term you might want to calculate. So I'm going to do that first. I'm going to find an expression for the nth term. And very often in a test or an exam, that will also be what they will be asking you. So, very easy really. Once you've identified what you are dealing with, you're just going to substitute in your values. So we've said already A is the 1st term, and in this series, the 1st term is 2. I'm not filling n in just yet, so I leave that n minus 1 as it is. D is the constant difference, and that's how much do you add or subtract to get from one term to the next. So to get from 2 to 5, I add 3, 5 to 8, I add 3. So the constant difference is 3. Now I'm just going to tidy this up a little bit. I'm going to multiply out that bracket over there. So I'm going to say 2 plus 3n minus 3. And if I simplify that, it gives me 3n minus 1. Now this is what we call a general term or an nth term. It's very important that once you've calculated your general term, that you just check that it works, guys, because very often these sequences and series questions can have 5 questions, and if you get the first one wrong, then the others are not going to go so well. So let's not be irresponsible. Let's quickly check whether our answer works. Now, I know that the 4th term is 4, right? Sorry, that the 4th term is 11. I know that the 4th term is 11. So I'm going to see now, does my general formula that I got here, does that give me 11 if I substitute 4 in the place of n? And you don't really need to do the calculation. You can just check this manually. So n is now replaced with 4 because I'm calculating the 4th term. And 12 minus 1, yes, that gives me 11. My formula works, so I can relax and I can carry on and actually answer the question that they asked me. And the question asked us to calculate the 1,000th term. And that is going to be 3 times 1,000 subtract 1, and don't need a calculator for that one, that's 2,999. Okay, so guys, important things to remember about linear or arithmetic number patterns. From one term to the next, you will add or subtract a constant value. That is how we identify that we are dealing with an arithmetic number pattern. Also, when in doubt, feel free to check the third term minus the second term must be equal to the second term minus the first term. Very important. And our formula Tn is a plus n minus 1d. A stands for the first term. D stands for the constant difference. That's whatever you add and subtract from one term to the next. And n deals with whatever term you want. If you wanted the fifth term, you would substitute 5 into the place of n. Right, guys, so that's the linear number pattern for now. Let's have a look, linear or arithmetic, at the other types that we get. And I can promise you guys, it gets quite exciting. Right, the next one is our exponential number pattern. Now, an exponential number pattern is also often called a geometric number pattern. And let's have a look at how a geometric number pattern is different from a linear number pattern, and they are quite significantly different. Have a look at this number series for me. It goes 2, then 5, then 18, then 54. Now, what I notice is that if I multiply 2 by 3, I get 6. If I multiply 6 by 3, I get 18. If I multiply 18 by 3, I get 54. So how is this different? To get from one term to the next, I am multiplying, and that value that I'm multiplying with is called a constant ratio. Something else that you can use to check if you're not sure whether your number pattern is exponential or geometric. If it is exponential or geometric, the third term divided by the second term must give you the same answer as the second term divided by the first. Right? So let's see. The third term is 18. 18 divided by the second term, 6, that gives me 3. And 6 divided by 2 also gives me 3. So I know for a fact that I'm dealing with an exponential or a geometric number pattern. So very important, that little bit of information. Let's have a look at this example that we are given. We are told 2, 6, 8, 54. So we've already spoken about that for a bit. And they want us to determine the nth term. So they could have also phrased this question, find an expression for the general term. That would also have been fine. So let's have a look quickly at how we would do that. The first thing, now that we've identified that we are actually dealing with an exponential number pattern, the first thing that's important is to find out what formula we need to be working with. So let's see, here's our formula, and this formula should be given to you. Tn is A times R to the power n minus 1. Now this formula can be used to calculate any term if the number pattern is geometric. But guys, it's very important, it has to be geometric. You can't go using geometric formulas for arithmetic number patterns. Right. So quite predictably, again, the A, as was the case with our linear or arithmetic, the A is the first term. So the first term in this number pattern is 2. So we're going to say Tn is equal to 2. Then R stands for the common ratio. So that is, what do I need to multiply with to get from one term to the next? And this one's pretty straightforward. I am multiplying by 3. And guys, this is now already the general term. Please, I just want to beg you guys, do not now go saying that 2 times 3 is 6. It's not true. This is not the same thing. So please don't do that. You can quite simply just write Tn is 2 times 3 to the power n minus 1. Just like that. Don't go doing all sorts of illegal things. Now, before we carry on to the quadratic number pattern, I just want to talk to you guys a little bit about what if I've got a number pattern that's geometric, but it's getting smaller. Let's have a look at this example. Starting off with 100, pretty straightforward example. Then the next term is 50. And the next term is 25. And so on and so on. Now, guys, you're probably jumping up and down and telling me, but that's easy. All you're doing is you dividing by 2. Yes, that's right. I am dividing by 2. But you can't say divide by 2 as your common ratio. You've got to tell me what you are multiplying with. So if you are multiplying and you want to get from 100 to 50, you will multiply by a half and multiply by a half. So your common ratio in this case is a half. Please, guys, remember that. Another way to check what your common ratio is to do this little check. The third term over the second term will give you the common ratio, as will the second term over the first. And of course, these guys need to be equal in order for this to be a geometric number pattern. So if I look at the third term over the second term, I get 25 over 50, which simplifies to a half. So the common ratio is a half, please guys, not 2. And also if you check the second term, 50 over the first term, 100, 50 over 100, of course, also simplifies down to a half. Right, so that is our geometric number pattern. Stuff to remember. Term 3 divided by term 2 is equal to term 2 divided by term 1. And the formula that we use for a geometric or an exponential, remember those two things mean the same thing, is Tn is equal to a r to the power n minus 1. Now, guys, we're going to move on to rather an exciting type of number pattern, and these are the number patterns that are neither arithmetic nor geometric, and they are called quadratic. Let's have a look. Now, quadratic number patterns, we say has the general term Tn is equal to an squared plus bn plus c. Now, before we carry on any further, let me just make up an example of a quadratic number pattern for you guys so you can see what is going on. So if I say 2 and then 5 and then 10, this will form a quadratic number pattern. Let me just see, I've added 3, I've added 5, now I'm going to add 7. So next term is 17. Now, if we apply the tests that we know so far for arithmetic or linear, geometric or exponential to this number pattern, none of them will work. If I go 10 minus 5, 10 minus 5 gives me 5. But 5 minus 2 gives me 3. So when I subtract, I don't get the same answers. So clearly, this cannot be linear, right? So then let's have a look quickly at our test for geometric. If I go 10 divided by 5, that gives me 2. But if I go 5 divided by 2, that gives me 2.5. So definitely it's not geometric either, and that's usually the clue. If it's none of the others, it is quadratic. But still, we need to check whether this number pattern is quadratic. So let's have a look at the identification. What we're going to start doing is we're going to start by having a look at the first difference. What I mean by first difference is, what do I have to do to get from 2 to 5? Well, I'm pretty sure I need to add 3. Then, what do I need to do to get from 5 to 10? I have to add 5. And from 10 to 17, I need to add 7. Now, there's definitely nothing constant emerging here, but this is my first difference. If I now look at the second difference, from 3 to 5, it's 2, and from 5 to 7, it's 2. This second difference is constant. And guys, this is how I test whether my number pattern is quadratic or not. Now, I want to tell you guys a couple of things that I've found to be quite interesting about quadratic number patterns and dealing with them over the years. If your number pattern is quadratic, what you will notice is that your first differences, so that's this first line over here, that's 3, 5, 7. The first difference will either be constant, like plus 1, plus 1, plus 1, plus 1, so they're all the same, or it will be an arithmetic number pattern, right? Sorry, guys, I just need to correct myself there. The first difference will be an arithmetic number pattern, so that's rather an interesting thing to look at. Now, in the case of a linear number pattern and a geometric number pattern, we just had a simple formula that we could apply. We could just punch we could put in the A and we could put in the R or the D, and there we have it. We have our general term. But in the case of a quadratic number pattern, it really isn't that simple. And there is a lot of different methods to get the general term of a quadratic number pattern. Now, what I'm going to do today is I'm going to show you guys 2 different methods, but it is absolutely fine to use whatever method you are most comfortable with. But remember, guys, if we work correctly, we should all get the same answers. So I'm going to start with the first method, which is my method. When I was teaching quadratic number patterns to myself a couple of years ago, this is how it made sense to me. It makes sense to some of my students, not to everybody. And then I'll show you guys the other method afterwards. Right. So basically what we need to do is we need to find the values of A, of B, and of C. Sometimes there isn't a B term, but that doesn't matter. So how I do it is I start off by saying to myself, what is my second difference? My second difference is 2. Now, the value of A, and that's the coefficient of the n squared, is always going to be half of the second difference. So if the second difference is 10, then A will be 5. If the second difference is 20, then A will be 10. In this case, the second difference is 2, so A will be 1. So far, I know I'm dealing with Tn is equal to 1 n squared, and then some other stuff. Then what I do is I make a table for myself. I say to myself, right, I want my first term to be, goes 2, 5, 10. So I want my terms to be 2, 5, 10, 17, right? That is what I want. Now, what I do is I put n underneath here. I say, I want my first term to be 2. I want my second term to be 5. I want my third term to be 10. And I want my fourth term to be 17, right? So I start off over there, and then I start substituting into this expression that I already have. And I say to myself, what do I get? And what am I short or over? No, this might seem very complicated, but actually once you practice it a bit, it's not too hard. If I substitute 1 into the place of n squared over here, I get 1 n squared, which is 1, right? So short or over, I am short 1, because if I add 1 to 1, I get 2. So let's try the next one. If I put 2 into that formula, I say 2 squared is 4, so I get 4. So what happens? I am short 1 again. And for 3 squared, I get 9, and I'm short 1 again. Now, to determine the rest of my formula, I look at this part. Now, this example that I chose is quite easy. All I need to do is say plus 1, and that's it. That's my general term. There is no B term. So this is a nice one because this just all worked out to be the same. In most cases, however, it isn't really this easy, but what you will notice then with your short or over part is that your short or over part will also form an arithmetic series. Your short or over part will form an arithmetic series, and then you can use this part of your arithmetic or linear formula, substitute your first term for A, substitute your common difference for D, and then add that to that Tn formula. So we're going to do some examples just now, so I'll show you guys how to do it. Then the other way that you can use to find your general formula actually also makes perfect sense. You've got to remember a little bit more, but it's not really any more difficult, and we'll talk about that in a second before we start our first example. So the other way to do it is to say to yourself that 2a is equal to the second difference, which is much the same as what I did just now. And then say to you the first of the first difference, the first term in that row of the first differences is 3a plus b, and that the first term, the actual first term of your series, term 1, is a plus b plus c. So that can also be used quite effectively to calculate the general term. So let's just quickly remember again, I had 2 and then 5 and then 10 and then 17. That was my example. And I said from 2 to 5 is 3, from 5 to 10 is 5, and from 10 to 17 it's 7. Now if you're using this formula, you'll again calculate your second difference, which is 2, and you'll go back and you'll say, right, 2a is equal to the second difference. So what does that mean? It means 2a is 2, so a is 1. So that's what you've found so far. Then you have a look at the next part of the formula. The next part of the formula says the first term of the first difference is given by 3a plus b. So the first term of the first difference in this case, it's that guy over there, it's 3. So we're going to set up another equation doing that. Going to say 3a, but we already know that a is 1, plus b is equal to the first term of our first difference, which is 3. And solving, then you get that b is 0. And that's right, because remember when I did it my way, I got Tn is n squared plus 1. There was no Bn term. Right. So b is 0. And now, finally, we're going to use the fact that a plus b plus c is equal to the first term. So the first term in my series was 2. So now I say a plus b plus c must be equal to the first term in my series, and I get that c is 1. So if I go right the way back to my general formula, that's 1, that's 0, and that's 1. So Tn is equal to n squared plus 1. Right. So a little bit more work involved in the quadratic number patterns, but so exciting, very, very nice. And it's not that hard to identify, guys, because just remember that you should know the rules for arithmetic, you should know the rules for geometric. If it's neither arithmetic nor geometric, It's probably quadratic, but make sure by calculating the second difference that that is in fact what you are dealing with. Now let's have a look at some exercises on these number patterns. Right. Now I think you guys will probably realize quite quickly that all of the number patterns in question 1 are linear. All of the number patterns in question 2 are exponential, and then question 3 deals with the quadratic ones. But remember guys, we're not going to get that lucky in a test or an exam situation, so I'm going to still go through the motions very carefully and make sure that I check it thoroughly. So question 1 says, determine the nth term of the following number patterns. Right. So let's have a look. From 4 to 9, I add 5. From 9 to 14, I add 5 also, and from 14 to 19, I also add 5. So I have decided, based on that evidence, that this is an arithmetic or a linear number pattern because there is a constant term of 5 that I am adding from one to the next. So once you have decided what sort of number pattern you're dealing with, you now select the formula that you're going to be using. And the appropriate formula in this case is Tn is equal to A plus n minus 1 D. And that is the formula to get the general term for arithmetic or linear. So A stands for the first term, so my first term is 4. Remember, if we're getting the nth term, we don't substitute anything in the place of D. Sorry, in the place of n, rather, sorry. D, however, is 5. And when you multiply this one out, we're going to get 4 plus 5n minus 5. So the nth term, if we can just simplify it as far as possible, is 5n minus 1. Remember guys, as I said to you before, you would be an absolute fool if you don't just quickly check. So let's see, our nth term is 5n minus 1. Let's calculate the fourth term using this formula. N will then be replaced by 4. So 5 times 4 minus 1 gives me 19. So I know that my formula works, thank goodness. Right, so that's question 1a. Moving along to the next one. Remember guys, we don't necessarily know that it's linear, so we really do need to check. What happens from minus 4 to 0? What do I need to do to get from minus 4 to 0? I need to add 4. What do I need to do to get from 0 to 4? I need to add 4. What do I need to do to get from 4 to 8? I need to add 4. So because there is a constant difference added from one term to the next, I know that it's linear. Writing down the formula, Tn is equal to A plus n minus 1 D. Remember guys, A stands for the first term, and the first term that we are given here is negative 4. We do not fill in n if we are doing the nth term. We do, however, have to fill in the common difference, and the common difference is also 4. Sorry, there's a plus between those two. Right. So just multiplying this out, I get negative 4 plus 4n minus another 4. So my nth term is 4n minus 8. Again, guys, you might think I'm overcautious, but let's just check. Our fourth term must be 8 according to this number sequence. So let's substitute 4 into the place of n over here and see whether we do actually get 8. If I put 4 in the place of n, I get 4 times 4, which is 16, minus 8, which is 8. So it works. Nicely done. Right, next one. The next one is our first one where we're actually going downwards. So our constant difference is we are adding something that's negative, because what do I do to get from 9 to 7? I subtract 2. To get from 7 to 5, I subtract 2 as well. And to get from 5 to 3, I subtract 2. So definitely this is linear, that's not a problem. And my constant difference is minus 2. Guys, I find that this is very often where people make a mistake. You guys know that they're subtracting 2, but somehow when you put it into your formula, you forget about that, and that's really just unnecessary. But hopefully you're going to check, so you won't have those sorts of problems. So Tn is equal to a plus n minus 1 d. A is our first term, that's 9. We don't know what n is, but the common difference is negative 2, guys, please. That's really important. And then 9 multiplying out, I'm going to get minus 2n plus 2. So 11 minus 2n is my general term. And what I'm going to do the fourth term again. I know that I want my fourth term to be 3. Let's see if I get 3 using this formula. 11 minus 2 times 4, because it's the fourth term, gives me 11 minus 8, which is 3, so it works. Right, sorry guys. Moving along to D. You guys see now, if you've done a couple of these, they actually become quite boring, and that's very important, is to practice to the point where you're bored. But we'll excite you guys again just now when we do some harder questions. From 5 to 1, I subtract 4. From 1 to negative 3, I subtract 4, and I subtract 4 again. So this is definitely linear, no doubt about that. And my constant difference is a negative number. Please remember that and fill it in that manner. Quickly substituting into the formula. I'm not going to write the formula again. You guys should know it by now. Tn is a, first term, 5, plus n minus 1 times the constant difference, which is negative 4. And this gives me 5 minus 4n plus 4, and that's then 9 minus 4n. Again, guys, you can check whether your answer is correct by substituting back into it. Right, then our last one, slightly different because this time we've got fractions, but honestly, it shouldn't be that much of a challenge. I know you guys get very frightened when you see fractions, but most of the time it's really not that bad. To get from 1 to 1.5, I add a half. To get from 1.5 to 2, I add a half. To get from 2 to 2.5, I add a half. Definitely this is linear, and my constant difference is a half. So Tn is equal to a, the first term, which is 1, plus n minus 1 times the common difference. And that gives me 1 plus a half n minus a half. And if I simplify that nicely, it simplifies to a half n plus a half. And again, guys, no reason to get it wrong. You can always check. Right, let's have a look at question number 2. Now, all three of the questions in question number 2 happen to be geometric number patterns, but as I said to you guys before, you still need to check. So let's have a look. What do I do to get from negative 2 to 4? Well, I've got to multiply by negative 2. What do I have to do to get from 4 to negative 8? Well, I've got to multiply by negative 2 as well. Now, this is a nice example because people are often confused when the signs alter. If the one is positive, the next is negative. The only way that that can happen really, if you've got alternating plus minus signs, if it is a geometric number pattern, and if the common ratio is negative. So that's really very important. Right, so we've established that we're dealing with a geometric number pattern, And what I'm going to do now is write down my general formula. So Tn is equal to a r to the power n minus 1. Right, so a stands for my first term, and my first term is negative 2. R is my common ratio, and my common ratio is also negative 2. And that is then to the power n minus 1. Now this can actually be simplified quite nicely because, remember just now I said to you, if you've got a 2 here and a 3 there, whatever you do, don't multiply them out because 2 times, and say that it's 6. But in this case it's slightly different. Because these bases are exactly the same, I can say, well, according to my law of exponents, I can now add some things over here. And I can say that this is negative 2 to the power n minus 1 from there plus 1. So actually the 1's cancel out. So this is a nice, elegant little simplification. It's negative 2 to the power n. And remember, you do need to have a bracket around that negative 2. That's very, very important. If this bracket is omitted, then it actually isn't correct anymore. Right, so that was the first one. Now the second one, we're dealing with fractions, and probably a bit easier if you write it as ordinary fractions, not decimals. So this number pattern goes 1, then a half, and then a quarter. So what on earth has happened here? Well, if you want to check, you can say a quarter divided by a half on your calculator, and you will see that that gives you a half. A half divided by 1 on your calculator, and you will see that that gives you a half also. Proving to us two things: that this is a geometric number pattern, but also that the common ratio of this particular geometric number pattern is a half. Right, so let's substitute this into our formula, and we're just going to simplify nicely. And I actually forgot to check the previous one, so we're going to make sure that we check this one. Tn is equal to ar to the power n minus 1. Right, the first term, a is the first term, and the first term is 1. R is the common ratio. I am multiplying by a half. So this one's quite straightforward. You can just write a half to the power n minus 1. And we know that the third term is a quarter, so if you put 3 in there, in the place of n, you get a half to the power 3 minus 1, so that's a half squared, which is a quarter. So that definitely does work. Last one of these guys. It looks like it's again a number pattern that's alternating between positive and negative. So multiplied by negative 3 and multiplied by negative 3. Definitely geometric. And our general formula is Tn equal to ar to the power n minus 1. Remember guys, a is your first term, and the first term in this case is 2. R stands for the common ratio. So what do I multiply with from one term to the next? And R is negative 3. And really guys, this one can't be simplified any further. And in fact, it'll be a huge crime if you multiply 2 times minus 3. Please, it's not minus 6. Don't even go there. Right, now guys, the examples that we've done on linear and quadratic so far have been relatively straightforward. All we've had to do is just apply the rules. But I want you guys to know and to expect that in a test type situation, the questions that we're going to get are going to be a little bit more practical. They're probably going to be a little bit harder. And I think if you guys look at the homework for this section, you'll see that the questions can get harder quite quickly. But the whole exercise with doing so many repetitive questions now is to make sure that your basics are in place. Now, moving on to question 3. And after question 3, I'm going to talk to you guys a little bit about some of the harder questions that you guys have for homework. Right, guys, so the question says, consider the following number pattern, and it goes 8, 18, 30, and 44. Now, I think it's obvious fairly immediately that this is neither a linear nor a geometric number pattern. Something else is going on here. They say determine the next three terms, the general term, and then the 20th term. Fine, that's not a problem for us. Let's just write down those numbers again, and let's see what sort of pattern we can see emerging. Okay, so the difference, the first difference, or the difference between the first and the second term is 10. We've got to add 10 to get from 8 to 18. To get from 18 to 30, we have to add 12. And to get from 30 to 44, we have to add 14. Okay, I said to you guys earlier on that if the number pattern is quadratic, what you'll notice is that the first difference will always be an arithmetic number pattern, 10, 12, 14, which it is. Right, so then the second difference from 10 to 12, it's 2, and from 12 to 14 is 2. So if ever you are asked to prove that you are dealing with a quadratic number pattern, this is what you do. You show them up to the second difference and you say, look, the second difference is constant, therefore it is quadratic. Now, we need to first write down the next the next three terms rather. So let's do that quickly. Now, if I added 14 to get from 30 to 44, and it's going up with 2 every time, surely the next term that I will be adding will be 16. Right, so the next term in my number pattern will be 60, because 44 plus 16 is 60. And then after that, 18, which brings me to 78. Right. There we go. And now we've got to write the next three terms. So the next one is going to be 20, which will bring me to 98. So the next three terms, 60, 78, 98, and you just really use the pattern to get there. Now I'm going to use, to find the general term, the nth term, I'm going to show you guys how to do that using two methods. And at least that'll give you guys some options as to what you might find easier. But very important, you can use whatever you want, guys, but we all need to get the same answers. That's the important bit. Right, so let's have a look at this number pattern again. It was 8, 18, 30, 44. And I said 10, 12, and 14. And my second difference is 2. So the fact that the second difference is constant means that we're dealing with a quadratic number pattern. Now the way I do this question, usually if I'm doing it on my own at home, I will start by saying A, which is the coefficient of n squared, is half of the second difference. Now the second difference is 2, so half of 2 is 1. But if your second difference works out to be 10, then your A term will be 5, and so forth. So I write Tn is equal to 1n squared, blah, 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 blah. Then I say, I want my first term to be 8. I want my second term to be 18. I want my third term to be 30. You only have to write down 3 terms. And then I check at this point, using my sort of half formula, what do I get? And then I have a look at what I'm short, over or short. Right. So if I substitute 1 into the place of n for that formula, I get 1, which means that I am a fool. I actually wanted 8, so I need to add 7. If I substitute 2 into that formula, I get 4, which means I actually want 18, so I'm 14 short. If I substitute 3 into that formula, I get 9, which means I am 21 short. Now what you will notice is this short or over, your last line, will either be constant, like plus 2, plus 2, plus 2, plus 2, like what we had earlier on, and then that's all you have to do is just add that constant number to your general formula. But in this case, this short or over bit of mine is forming an arithmetic series, and it always will either be a constant or an arithmetic. And I'm just going to substitute into this formula. So I'm going to say the first term of this short or over business is 7 plus n minus 1, and the common difference is 7 because I had 7 to get to 14 and so forth. And when I multiply this out, I get 7n minus 7 and plus 7, which means that, boys and girls, is my general formula. So there's no C term. Again, there's so many places where you can go wrong, especially with these guys. So let's check whether if I put 3 in the place of n in this term, in this formula, I do in fact get 30. So 3 squared is 9, plus 7 times 3 is 21. 9 plus 21 does give me 30. So this formula works, which is really cool. Right, but now let's also have a look at the other method that you can use to solve these guys. Some people might think that my method is all silly and it's just complicated and all sorts of tables, but guys, you must just do whatever you are more comfortable with. Right, the other method involves much the same in the beginning. It says that 2a is the second difference, and the second difference is 2, so a is 1. Right? Then, furthermore, it says that the first term of the second difference is 3a plus b. So 3a plus b equals, and let's have a look at what is this first term of the second difference. First term of the first difference, rather, 10. So that's 10. So I'm going to say 3a plus b is 10. But I already know that a is 1. So 3 times 1 plus b is 10. So b is going to be 10 minus 3, which is 7. So that works out all nicely. And then finally, we are told that the first term, which in this case is 8, is equal to a plus b plus c, right? But I already know that a is 1 and b is 7. And if I solve for c here, I get that c is 0. And that comes down to exactly the same thing. Your general term will be n squared plus 7n. Right, so we found that, but now they've also asked us to calculate the 20th term, and that's not going to be hard now. It's just simple substitution. So Tn is equal to n squared plus 7n. We need to calculate term number 20, and that is going to be 20. Sorry, my bracket's the wrong way around there. 20 squared plus 7 times 20. If I'm not mistaken, that's 540, but let's not take any chances. Plus 140, yeah. So that's correct. 540 is then the 20th term. Right. So it really doesn't matter how you decide to do the question, as long as you do something that you find comfortable. That was question 3a. Now let's have a look at question 3b, and I've got a sneaking suspicion that this one is also going to be quadratic. Let's have a look. Minus 3, minus 2, then minus 3, then minus 6, and then negative 11. Consider the following number pattern, and we firstly need to write down the next two terms. Now, there's no use writing down the next two terms, or we can't really do that if we don't know what sort of number pattern we're dealing with. Now, it looks to me as if it's definitely not geometric or arithmetic, really. So let's have a look. I'm suspecting it's probably quadratic. So what do I need to do to get from -1 to -3? I need to subtract 1. What do I need to do to get from -3 to -6? I need to subtract 3. What do I need to do to get from -6 to -11? I need to subtract 5. So this is already forming a bit of a pattern, so I'm suspecting that I'm probably on the right track. What is the difference between -1 and -3? That's -2, and -2 again. So definitely our second difference is constant, so we're definitely dealing with a quadratic number pattern. So you guys, right. Now what we're going to do is we're just going to apply the same rule to find the value of the next two terms. So the amount that I subtracted increased by 2. So that means that in the next jolt, I will be subtracting 7. And if I subtract 7 from -11, that becomes -18. And you see that keeps the second difference constant at -2, so I know that that's right. And the next term will be -9, which will make that -27. So no problems there, really. Once you've established what sort of number pattern you're dealing with, it's really pretty easy to find out what you have to find out how to get to the next term. Just remember that this second difference has to remain constant and that the same pattern must be followed for your first difference. Okay guys, so the next question says to determine the general term for the number pattern, and I'm going to use the method where I start by saying 2 times A is equal to the second difference, and it's -2 guys, so remember to put -2 in, which obviously means then that A is -1. Then 3A plus B is equal to the first term of the first difference. So let's have a look quickly. What was that? The first term of the first difference was -1. So I'm going to say, well, that's equal to -1. But I've already calculated that A is -1 also. So solving this equation, I get that B is -1 plus 3 as it comes to the other side, so B is 2. And then finally, A plus B plus C is the first term. Let's just use a different color for that in case we get confused. A is -1 plus B, which is 2, plus C is equal to the first term of our number pattern, and the first term of our number pattern was -2. So solving for C, I get a 1, and if I take it to the other side, I get that C is -3. So if my calculations are correct, but I'm going to check them in a minute, Tn is equal to -n squared plus 2n minus 3. So that is my general term. Now, especially in a question such as this one, where I've still got to do other questions as well, you don't want to be struggling away with a general term that's not correct. So let's quickly use it just to calculate the value of the second term. So if I say 2 in the place of n, because I'm looking for the second term, I get 2 squared with a minus in front, so that's -4, plus 2 times 2, that's +4, they cancel, and I get -3, so that works. Right. There's yet another question, and this is why I said it's so important that we get this guy right. So we know now that our general term is correct, and they say to us, which term of the number pattern will be -83? Now, whenever they say which term, they are asking us to solve for n, right? Please, guys, don't go putting -83 in the place of n. Yeah. What's wrong with it?
As
Oh, sure.
The jacket closes at the front.
Okay.
And it just touches.
Okay. Yeah, I think that should be better. Okay.
So we just go.
To which? To the start of that question. Yeah.
Okay. And we can go in 3, 2, 1, action.
Right, guys. So the next question says, which term of the number pattern is minus 83? Very, very important that we remember when they ask us the question, which term, they are asking us to solve for n. So which term means solve for n, give me an answer for n. Now, guys, n is a position. It's the term number. It could be the 5th term, the 8th term, the 10th term. And remember that this is very, very similar to a place in a race. If you run a race, you can come 4th, you can come 5th, you can come 10th, but you can't be so bad that you come negative 10th, right? So when you are solving for n, remember that your answer has to be firstly positive, and it has to be a whole number. It can't be 1,5. If you do get an answer and you wrote correctly, that's not a whole number. What that means is that there isn't actually a term that's minus 83. It's somewhere in between. So very, very important, which term means solve for n. Right, so we're going to write down quickly our general formula, which was minus n squared plus 2n minus 3. And I want to know which term, Tn, is minus 83. So the minus 83 goes into the place of the Tn. I don't know why this happens, but there's so many of you guys that will now put minus 83 in the place of n. Guys, don't do that. Right, so this is a trinomial. I'm going to have to solve this baby. Let's bring everything over to the left-hand side. So that becomes plus n squared minus 2n, and the minus 3 becomes a plus, making this negative 80. Right, remember guys, if you're finding this difficult to factorize, especially if the numbers are very big, what you can do is use the quadratic formula. All right, so we are looking for the factors of 80 that can possibly give us 2 in the middle. Now, I haven't done this one before. Now, I'm getting stuck. So let's try some things. Factors of 80, what about 20 and 4? No, I don't think that's going to work. What about 10 and 8? I think 10 and 8, that could work. Yes, we'll make it minus 10 plus 8. That works perfectly. And I get 2 answers. Either minus 83 is the 10th term, or minus 83 is the negative 8th term. Now remember what I said to you guys, you can't be so bad in a race that you get a negative position. So just cross out that solution. If there is one that gives you a negative, cross it out. And remember that you are looking for an answer which is a positive whole number. Right, so this question was a little bit more involved, and this is what we can expect. It starts off easy, but we've got to be able to do questions that are more multi-step, that require us to do a little bit more thinking. So let's have a look at the last question. Question 4, for all of 9 marks. So the question says, determine which term in the number pattern 8, 10, 16, 26 equals 170. Now, the reason why this is for so many marks is because firstly, we're going to have to determine the general term before we can even worry about which term is equal to 170. And it's pretty clear to me that this one is quadratic, but let's just make sure. From 8 to 10, I add 2. From 10 to 16, I add 6. From 16 to 26, I add 10. This is forming an arithmetic pattern, so that's encouraging. From 2 to 6, I add 4. From 6 to 10, I add 4 as well. So our second difference is constant, which means that it is, in fact, quadratic, just like we expected. So we're going to say, right, 2a is equal to the second difference, which is 4. So A is equal to 2. That's the first bit. Then I'm going to use the fact that 3A plus B must be equal to the first term of my first difference. There's the first term of my first difference. That's 2. I've already determined A. So 3 times 2 plus B is equal to 2. So B will be -4 if I take this over to the other side. Only one more variable left to calculate, and that is C. Now remember, we also know that A plus B plus C is equal to the first term of our sequence, and the first term in our sequence was 8. So we put that equal to 8. Luckily, we already know that A is 2. We know that B is -4. And with C added to those guys, we need to get 8. So C is equal to, that's -2, and that's 10. Right. So my general term is Tn is equal to 2n squared minus 4n plus 10. That is my general term, and remember guys, I've said to you before, you'll be a fool if you don't check. So let's have a look. We know that in this number pattern the second term is 10. So let's see if I substitute 2 in the place of n for the second term, do I actually get 10? If I don't, I've got problems. And I can already see that this is going to work like a charm. Those two cancel. And yes, I do get that the second term is 10, and that was not asked for me because I can see that the second term is 10. They've given me the number pattern, but all I did, the only reason I did that was just to check whether my solutions are correct. Right, so the actual question said, which term equals 170? So what I'm going to do is I'm going to remember that whenever I'm asked which term, what I need to do is I need to solve for n. And remember, n must be a positive whole number. And the which term, the term that they ask me, which term is 170, that goes in the place of Tn. Now from here onwards, it really isn't even sequences and series anymore. It's just a bit of equations, not so bad. So the 170 comes over, we add the 10 to it, and we get minus 160. Now I'm just quickly going to divide by 2. And aren't these the factors that I got just now as well? Goodness. Very similar, yes. So I'm going to say n minus 10, n plus 8. Again, I will get n is 10 for my one solution. N is minus 8 cannot be a solution because, remember, n is like a place in a race. We can come first, second, third, fourth, but we can't be so bad that we come minus 10th. Right, guys, that's the end of our actual lesson questions. But I just want to talk to you guys a little bit about some of the questions in your homework. Particularly, I want us to talk about question 1, which is a nice question that's from a past paper. And that's a really nice practical application. And I just want to give you guys a couple of hints so that you don't say, oh, but the questions that we got for homework were just so bad, I couldn't do them. So if you guys look on your notes, you'll see you've got the 3 triangles over there. Now, I'm not going to try and draw them too nicely. Let's just go with it. You've got one triangle, then a next triangle, and then another one. So the triangles are getting bigger, and the perpendicular heights of the triangles are given. For the first triangle, it's 2 centimeters. For the second triangle, it's 3 centimeters. For the fourth triangle, it's 4 centimeters. So there's definitely a sequence happening with the perpendicular heights. The heights are going up by 1 centimeter from one triangle to the next. But then let's look at the bases of the triangles. The first triangle has got a base of 2 centimeters, the next of 4, and the next of 6. Right, guys, so it's very interesting to see what's happening with these 3 triangles. We've got an arithmetic number pattern for the heights and for the bases, but the first question asks us about the area. Guys, read your questions. I cannot stress this enough. And I'm going to give you guys the hint that area is equal to base times height over 2. Now, what you need to do in this question is you first need to calculate the area of the first triangle, the area of the second, the area of the third. Now, what you will see is that they form a number pattern that go 2, 6, and then 12, right? Because it's base times height divided by 2 is 2, base times height divided by 2 is 6, and base times height divided by 2 is 12. So that is my hint for this question. Don't just work. What you could alternatively do is, if they ask you for the area of the 100th triangle, the other thing that you could do, if you're not going to write down the new areas, you will need to calculate the height of the 100th triangle and the base of the 100th triangle, and then apply them to this formula. But it's very, very important that you answer the actual question. So read it carefully. I'm not doing the whole question for you guys, but I just thought a clue or two would be in order. And I want to give you guys another clue before we finish the show. Have a look for me at your homework questions at question number 5. We've got a very interesting pattern here. It goes 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9, 10, and 11, 12, 13, 14, and 15. Now, I love these number patterns so much because I just think they're so exciting, and you can see all sorts of patterns whether you look around that side or that side. Now, this question says to us, determine the middle term of the 51st row. And this is my clue to you guys. The middle term are these guys. 1, 5, 13. The middle is going to stay the same, right? It's going to stay directly underneath each other. So what you need to do is don't worry about the rest of the numbers. Look at 1, 5, and 13 and try and come up with a general formula for 1, 5, and 13 and then calculate the 51st term. That would be my clue for this one. But the questions in the homework section are really very exciting, and if you've mastered those, then you can feel really, really confident that you've mastered the art of number patterns. Guys, so just to recap on the highlights, we had a look at arithmetic or linear number patterns. Arithmetic or linear number patterns, we added or subtracted something constant from one term to the next and very simply used this formula. A stands for the first term and D for that constant value that you're adding or subtracting, right? If you've got an arithmetic number pattern, the difference from one term to the next is the same. So you can say that this is true. Then for our geometric or our exponential number patterns, that is if we are multiplying by something constant, and here's our general formula, it's Tn is equal to A plus n minus, I'm talking absolute nonsense, sorry guys. It's Tn is equal to A r to the n minus 1. And of course here we are dealing with a common ratio, and this is true for a geometric number pattern. The third term divided by the second is the same as the second divided by the first. Then the quadratic number patterns, what we needed to do to establish whether they're quadratic or not is we had to get down to the second difference. Remember, if the second difference is constant, then we know we are dealing with a quadratic number pattern. And this is the general formula. And there's really various different ways to calculate the values of A, B, and C. But important to remember that 2A is the second difference. 3a plus b is the first term of the first difference, let's call that FF, and the first term of the number pattern is the first plus the second, is a plus b plus c. Right, guys, we hope that you've enjoyed this lesson on number patterns, but more so than that, I hope that you guys have learned something from it. It's actually quite an easy section. You just need to practice, and please, guys, before you start doing anything, identify the type of number pattern that you're dealing with. See you again.